Hey you, what's the derivative of Amazon? It's Amazon Prime. All right, athletes, so let's dive in here and let's see how calculus, right, taking these derivatives are going to help us answer these questions. So here's our first question. Determine the intervals upon which the given function is increasing or decreasing. And here's our function. F of x equals 3x cubed plus 15x squared. All right, so what I did is I used our friends over there at Desmos and I graphed this function for us. Of course, these functions aren't always gonna be this nice, but what I want us to do is relate the function to the graph so we could visually see what it is that we're finding, right? Because this was always a mystery to me. When I was a student, I'd be good at doing the math and following the steps, but sometimes I didn't know what the heck I was really doing, right? I don't want that to happen to you. So let's look at our graph here. And what I'm interested in is, where is this graph increasing? Well, here, looking at the graph, it's easy to see, right? It's increasing from negative infinity all the way up to this point right here. And this point right here, it's not too clear, right? It looks like it's going to be a decimal. And this is why this is a great problem, because we're going to see the value in finding the derivatives to help us find that exact point, right? And where else is it increasing? Well, we can see it's also increasing from 0 all the way to positive infinity. All right, where's the graph decreasing? Where's that interval? Well, again, from this mystery point all the way down to 0. So again, what we're looking is for these intervals. And when we write these intervals, they're going to represent these x values, right? So what we said is from negative infinity to whatever this x value is right here, right? And then from this mystery x value all the way to 0, and then from 0 to infinity, these are going to be the different intervals. And the first interval, we're going to see the function increasing. Second interval, our function is decreasing, right? It's falling. And then our last interval, the function's increasing. So now let's get into the math to see how these derivatives are going to help us out. All right, so just like in our little cheesy joke that we started off class with, we're going to take f prime, right? We're going to take the derivative of this function. And when we take the derivative, right, it's going to tell us, what is our function doing? Is it increasing or decreasing? That's one thing it helps us with. So let's go ahead and take the derivative, and we're going to get 9x squared plus 30x. So make sure you brush up on your derivative rules, or else this is going to be very challenging. All right, so now I'm going to go ahead and set this equal to 0. And what that's going to help us do is find our critical points. And one way you can think about your critical points is it's going to help us find this relative max, and it's going to help us find this relative minimum, okay? And because I know that's when the function is changing from increasing to decreasing, and I know when it's changing from decreasing to increasing, right? So it's going to help us find these intervals. That's what setting this equal to 0 does. So let's go ahead and set our function, oh, how'd that happen, equal to 0. So we get 9x squared plus 30x. And so if you're wondering, hey, Dr. Math, what's going on down here? Well, I'm going to show you. What I did is I took my original function in blue, and I also used decimals to graph the derivative function next to it. So we this green graph right here, this parabola, so we could connect the dots here, right? So we'll talk about this in a second if that's distracting. So let's go ahead and solve this. So let's factor out GCF, which is a 3x, and we're left with 3x plus 10. And again, remember, you could always check by multiplying, and if you multiply, it better give you what you started with, or you jacked up somewhere. All right, so now we have our two factors. So let's take each one of those mother factors and set them equal to 0. So we get 0 equals 3x and 0 equals 3x plus 10. So we're going to solve each one of those equations. Divide by 3, divide by 3. So we get x equals 0. Subtract 10 here, subtract 10 here, and we get 3x equals negative 10. Then of course we're going to divide 3 from both sides, and we're going to get x equals negative 10 thirds. So what do you know? So x equals 0, that's that value right there, right? So our x value right there is 0. We knew that. The one we didn't know, let me drop this down, was this guy right here, right? This peak. So this peak, relative maximum, the x value is negative 10/3. So if we divide that in our calculator, we get negative 3 point and then these decimals. So it's about right there. And that's going to set up the scene so that when we graph these intervals, right, we're going to use these intervals to help us see, you know, what is our graph doing in those intervals. All right, so follow me to the next part. All right, so let's go ahead, and I took those zeros, right, and I put them on our number line because this is what's going to create our intervals here. So if I just draw like a little imaginary line here, and what we're going to see is we're going to have interval, I'll just call it interval 1, interval 3, 2, and interval 3. So we have 3 intervals here. And what we want to do is we want to see, you know, what is f of x? What is f of x doing inside of these intervals? Is it increasing, right? Is it going up? Is it going down? What's going on here? So, and so far it's matching what we expect, because look at, we know it's increasing, that's interval 1. Then it changes to decreasing, that's interval 2. And then interval 3, we see it increasing again. So that's what we should find here, right? Whatever we find here should match what our graph is telling us. All right, so let's look at that, and then we'll relate it to the second, to the derivative down here. All right, so how do I know, using these numbers, how do I know if the function is increasing or decreasing? So we took the derivative, it helped us find these intervals here, right? Now what we're going to do is we're going to pick some numbers inside of these intervals, right? So I'm going to pick, let's say, -4. You can pick whatever number you want. I'm doing a different color. I'm going to choose -4. And what I'm going to do is I'm going to plug in -4 into the function f prime. So right here, I'm going to plug in -4. So do that with me. Take out your calculator and plug in -4 for x here, and plug in -4 for x. So go ahead, let's do that, and let's see what we get. So I'll take out my calculator, and you do it with me, because again, you need practice making sure you also know how to operate your calculator properly. So we should be getting -4, 24. And the number actually doesn't even matter. What matters is its sign. That's what we want to get here. So we get a positive from here. And because we get a positive, right, that's what I'm really interested in. What that tells us is that our function there on this interval from -infinity to -10/3, our function is going to be increasing. So that's what that positive means right there. So write that down. When you're looking at f prime, you plug in a value, right, in a certain interval. That outcome, if it's positive, that tells you your function is increasing. If it were negative, it would tell us the function is decreasing, right? And so far, this matches exactly what we expect. Let's pick another number, all right? Let's go ahead and plug in -1. So we're going to find f prime of -1. So wherever you see a x here, we're going to plug in -1. So do that with me, all right? So now we're going to plug in -1, and then get that practice in there with me. Make sure you know how to use your technology. And we get -21. And again, the only thing we want to pull from there is it positive or is it negative? And since f prime is negative in that region, we know that our function is decreasing. And that's exactly what we see here. Our function is decreasing from -10/3 all the way to a 0. So from -10/3 all the way to 0, we know our function is decreasing, right? And now we're going to pick a number greater than 0. So let's go ahead and just choose 1. So now we're going to find f prime of 1. And the biggest mistake I see mathletes all across the world doing is they're accidentally plugging these numbers into f of x. No, we're not using f of x. We're using f prime. We're looking at the derivative, right? That slope. what is the slope doing? All right, so let's go ahead and plug in positive 1 now. So let's do that together. And then what are you guys getting? 39. Good. So we get 39. Again, the only thing we care about is that it's positive. So we get positive, which tells us in this region, our function is increasing. And so that's what we're looking for in this question, right? We're trying to determine where is our function increasing and decreasing. And so let's write this down. Our function is increasing, right? It's increasing, and we said from negative infinity to negative 10/3, right? It's increasing from negative infinity all the way to negative 10/3, and it's also increasing, right? There's also another place where it's increasing, so we have a gap right in the middle. So we got our union. It's also increasing, I'll put a comma, from 0 to infinity. From 0 to infinity. All right, those are the places where it's increasing. Where is our function decreasing? Well, it's just decreasing right here in that middle, this region, from negative 10/3 all the way to 0. So it's decreasing from negative 10/3 all the way to 0. And there we have our intervals, all right? And so some people might ask, well, why do we even want to graph the derivative here? Well, notice what we did. We took the derivative and we set the derivative equal to 0, right? That's what helped us find these values right here, these critical points. And so what I wanted to show you is when you actually take the derivative and graph it, look at these zeros right here, right? These are the special numbers that we were looking at. There's our negative 10/3, right? And there's our 0. And we could see how everything to the left of negative 10/3, look at where our graph is. Our graph is on the positive side. It's above the x-axis. So to the left of this, our graph, right, is, let me make it nice and dark, is positive. It's above the x-axis, right? In between negative 10/3 and 0, look at where our graph lies. It's below 0. It's negative, right? And then to the right of 0, we see that our graph is above the x-axis. It's positive. And again, it just matches everything we've been saying, because we know when our derivative is above the x-axis, we know in that region the function is increasing. And that's exactly what we saw. So again, we're just making 100% sense with all this notation, these graphs, making sure everything's saying the same thing, because this is a challenging section and I just want to make sure it makes 100% sense to you. So follow me, if you will, to the next example. All right, another thing I want to talk about is a question many people ask is about relative extrema, right? And so what we're looking at is where is our function at its maybe its highest point or at its lowest point. So let's take a look at this function right here, right? And I just use decimals to graph it, and we could see, you know, that our lowest point right is going to be at 0 right there, right? The height, the lowest height is at 0, right? But again, let's use our derivatives and these ideas to help us out, so we could connect the dots. Because again, I don't want us just to follow some steps, because that's what the book says. Let's make sense of everything. So let's take the derivative, and we'll talk about y. So we're going to take the derivative, so we get 4x cubed plus 64 in this case x. And again, all we did, right, power rule, we brought down the 4, and then we dropped down our exponent by 1. We dropped down the 2, right, and then dropped our exponent down by 1. All right, so now what we're doing is we're going to set this equal to 0. So once we set f prime equal to 0, that's going to give us our potential maximums or minimums, right? So that's what that does right there. So if you didn't get that before, make sure you write that down. Setting this f prime equal to 0, that's what's going to help us find these peaks, if I had a peak, or a valley, right? The lowest points. So that's what it's doing, all right? So here we're going to go ahead and solve this, right? Solve this equation. So let's go ahead and factor out a 4. Let's factor out a 4x. So once you factor out the 4x, you're left with x squared. and then plus 16. All right, and so now that we factored it, we know our zero product rule. We're going to go ahead and set each one of these factors equal to 0. And some of you might be worried, like, wait a minute, I'm getting 2 answers, but right now I only have 1 minimum. What's going on here? Well, let's finish this off and then we'll know. So let's go ahead and divide both sides by 4. Divide by 4, so you get x equals 0. Subtract 16, subtract 16, you get x squared equals negative 16. So for sure, one of our zeros is that x equals 0, and we knew that from our graph, right? We knew that. And here I take the square root of both sides. So let's take the square root of both sides, take the square root of both sides, but what we're going to notice is we're going to get an imaginary number, right? I don't know where that negative came from, plus or minus, right? So we get an imaginary number right there. And so this, right, is not going to be a real 0. So our only, how do I know if this is a maximum or minimum? I was going to say minimum because I'm cheating, right? I'm looking at this graph right here. I also know about x to the 4th power. My leading coefficient is 1. But if I didn't know that, how would I know if this is a max or a min or a relative, right? One of these extrema. Well, this is where we get into our sine test. So there's so many different things we could do. This is what makes this awesome. So what I'm going to do is I'm going to use the sine test that we've been looking at, and I'm going to plug in. I'm going to look at f prime, and I'm going to do some test points. I'm going to look at a test to the left, a point to the left of 0, and a point to the right of 0. So let me plug in -1, right? So I'm going to find f prime of -1. And just like we did before, the only thing I'm interested in is the outcome. Is my outcome positive or is it negative? So if it's positive, I know my function is increasing. If it's negative, I know my function is decreasing. So f prime, notice this is my f prime right here. And if you want, I'm going to look at it in factored form. So if I plug in -1, I'm going to get a -4. I just care that's negative. Times, I'll plug in -1 here, and this will be positive, right? Because this is +1 plus 16. So I get times a positive. So on this side, I end up having a negative, which means to the left of 0, my function is decreasing. And let's take a look at our actual graph here. We could see to the left of 0, look at my function, it's decreasing. So exactly what I expected. Now let's plug in a number to the right of 0. So let's plug in, I don't know, 1. So f prime of 1. So again, I'm going to go to my original function and plug in 1. I'm going to go to its factored form. I'll plug in 1 here and I get +4. So I get +4, and actually, let me just write plus. All right, and then I'm going to plug in +1 here, and I'm going to get a positive as well. So I'm going to get a positive times a positive, and that's going to give me a positive product. So my answer is going to be positive. I don't care what the answer is, I just want to know its sign. Since it's positive, I know that in this interval, my function is going to be increasing. So actually, let me highlight this in blue to tell myself in this interval, my function is increasing. So let's think of this. To the left of 0, my function is going to go down because it's decreasing. I hit 0, and then everything to the right, my function is going to be increasing. So that's what tells me that what I found right there is a minimum, right? So that's what we found right there, a maximum, or sorry, a relative minimum. And actually in this case, it's going to be an absolute. How do I know it's an absolute? Well, if I look at my graph is going to shoot off up in this direction and up in this direction, right? So there's going to be no other points whatsoever that are actually going to be lower than this height right here of 0, right? And let's say I didn't know that height, because remember what I found is I found this x value. Well, what you would do then, right, to get that height, it's easy to see what that height is here, but what you would do is you would actually take that 0, right, that critical value, and you would plug that into your original function to get your height. So let's do that. Let's plug in into your original function. We're going to plug in that 0. So 0 we get 0 to the 4th power plus 32 times 0 squared. And of course, everything's zeroing out. And so you end up with your height of 0. So that point right there, just like we expected, is 0, 0. And there you have your absolute minimum. All right, hopefully this is making sense. And again, don't forget to smash that like button, right? Follow us to our next example. All right, mathletes, we're about to up our game right here, right? So here's a fun problem. So we have this function right here. And again, I use decimals to graph it. And we could see, right, some interesting things going on. And there's some things that are really hard to see, even with the graph. And what we're asked to do is to find a relative maximum or minimum, all right? So be careful because again, even though you might have a graph, it's sometimes almost impossible to get the information that we need from this graph, all right, just by looking at it with the naked eye. Sure, you could use technology and have it spit some information out to you, but I want us to get comfortable with these derivatives and show you the power behind them. All right, so we're looking for our maximum, minimum. Let's go ahead and take our derivative just like we did before. All right, so let's go ahead and take our derivative. So we're left with 1 plus this right here. I'm gonna rewrite it as 16 times x to the negative 1st power. So I'm just using my exponent rules to rewrite this so that this looks easier, right, to take the derivative of. So when I look at this, I'm gonna bring that -1 to the front, and then I'm left with 16x to the negative 2nd power, okay? So again, whenever you have maybe the variable on the bottom, you could use this, right? Your exponent rules, just to make things a little easier to take the, to differentiate. All right, so now we're gonna set this equal to 0 to find our possible critical values. So let's set this derivative equal to 0, and then we're gonna have negative 16x to the negative 2nd power. So let's go ahead and solve for x. So I'm gonna go ahead and add 16x to the negative 2nd power to both sides. Negative 2nd power. All right, sorry, that's messy. So we're left with 16x to the negative 2nd power equals +1, all right? And then we could go ahead and divide both sides by 16, or you could rewrite this. So remember what this -2 means, all right? This exponent -2, I could just rewrite that using our exponent rules as 16 over x squared. So again, this negative exponent, I could just bring it out. This negative exponent, I'm thinking derivatives, when I'm rewriting it, I could just bring it out, bring it to the bottom here. All right, so again, just make sure you understand and you're comfortable with your power rules, right? So what rule am I using? Let me write it over here. X raised to the -a, that's the same thing as 1 over x to the a. So that's the power rule that I'm using right there of exponents. All right, so now this is where we're at. All right, this is where we're at. So I'm gonna go ahead and multiply both sides by x squared. And I could do this because I know that x is not equal to 0, right? 0 is not part of our domain because look, I can't divide by 0. So 0 is not part of the domain. I don't have to worry about that. So what are we left with? We're left with 16 equaling x squared. And now I could take the derivative. I keep wanting to say derivative, the square root of both sides, right? Too many videos for today, for you guys today, mathletes, right? We earned a subscribe right there, right? We've been grinding at this all night for you guys. So I take the square root, and when we take the square root, we're left with the plus and minus, right? So we're left with the plus and minus. So we get x equals plus or minus 4. So now those are our two possible critical values. So what I'm gonna do is I'm gonna plot these in a number line, because once I get that number line set, and I plug in points, that's what's gonna tell me if this is a potential max or min. All right, so let's get our number line set up. Follow me. All right, mathletes, so let's go ahead and use those two critical values, and we're gonna make our line here, right? So we could find those intervals where the function is increasing and decreasing, or when it goes from decreasing to increasing. because that's going to help us find a relative maxima or relative minima. All right, so there's that -4 plotted and that 4 plotted. And what we're going to do is we just take a test point. So I'm going to plug in x is -5. And remember, you're plugging it into your derivative function. So when you plug that into the calculator or do it by hand, what you're going to see is that you're going to get a positive outcome. And so that means to the left of -4, our function is going to be increasing because we got a positive derivative, right? So we go ahead and plug a number in between -4 and 4. Don't plug in 0, it's not in the domain. So I'll plug in 1 or -1 or -3, any of those numbers. And what you're looking for again is the sign. So our sign is negative. So that tells us in that interval, our function is going to be decreasing. So look at what we know so far. So it goes from increasing to decreasing. So that means right there at -4, we found a relative maximum, right? A relative maximum. Tongue twister for me. All right, so we got a maximum right there. And then now we could go ahead and plug in a point greater than 4. So let's go ahead and plug in 5. And so we plug in 5 into f prime, and what you're going to see is you're going to get a positive answer. You don't care what that number is, as long as you're just looking at if it's positive or negative. So here it's positive, so what that tells me is to the right of 4, you're going to get your function to be increasing. So look at what we saw. To the left of 4, it was decreasing. To the right of 4, it was increasing. So that's going to give us a relative minima. So relative minima, right? And there you have it. And if you look at our graph here, it's really hard to see that. So again, this is where the derivatives, taking the derivatives is very helpful. And again, we haven't found those exact points. If you wanted the points, what you would do is plug in -4 into your original function. So let's do that. Let's plug in the -4 into our original function. So you get -4 plus 16 over -4. So you get -4 minus 4, which gives us -8. So your maximum is at -4 comma -8. Let's do the same thing to find the minimum. I'm going to use that 4 and plug it into your original function. And you get 4 plus 16 over 4, which gives us 4 plus 4, which equals 8. So our minimum in this case happens to be at 4 comma 8. And boy, mathletes, that was a mouthful. So hopefully these examples really help you out, helping further deepen your understanding of what the heck is going on. So again, help us out and subscribe to our channel, like, and tell a friend or two about the great things we're doing here for you. We'll see you, mathletes, in our next video. Peace.